This is a quick demonstration on how you can use Excel to graph your laboratory information. Well, first we'll open up Excel, and first thing you'll want to do, and this is for the particular lab that we just did where you had the cart rolling down the ramp and we were to graph the position. First of all, we'd have a column here for time, and you always want to put your unit that you use to measure it up above, so seconds for time. And then we also measured position, and the units there could have been centimeters or meters. I'm not sure what everybody used. Centimeters is usually easiest to see on the meter stick. So centimeters and time. And our time interval, if you used the spark timer on 1/10 or on 10 hertz, that means 1/10 of a second would be your time interval. So we'll put in 1/10 of a second intervals, so 0.1, 0.2, and I'm going to go ahead and just highlight those cells like this by clicking on the one. You click up above and then drag down with the mouse, and then I'll hold over the bottom right corner over that little black box right there, and then notice it turns the cursor to a plus sign like that, and then it'll allow me to drag that pattern that I just created down farther. And so we'll go ahead and drag it down to there. You might need to go more than 2 seconds, but 2 seconds will be sufficient for this demonstration. Next, we'll put in the positions at each one of those given time intervals. So each one of your dots representing 1/10 of a second. So the first dot from the starting point, we'll say how far it was, and I'm just going to make up some numbers because I, of course, don't have a ticker tape in front of me to show the actual positions. We'll say that there's 0.3 from the start, 0.7 from the start, 1.2 from the start, 1.9, and I'm just making these up as I go here. It doesn't really matter what I put, but I would like them to look kind of like what your data would be. Alright. And I'll put a few more, and that'll be it. 0.4. 13, I'm making them up here, 17, okay, far enough. Now if, instead of measuring from the start position and measuring which or where every one of the dots was with the meter stick, instead you measure the distance between consecutive dots and then wrote those distances down, I'll show you how to do that later. So stay tuned for that. I'll show that immediately after I finish showing this. But if you did it this way and showed the position, then we're good to go. I'll go ahead and highlight these, and again I do this by clicking up on the cell to the top left and then dragging it down and over the adjacent cells until they're all highlighted like so. And then you'll go to the insert up at the top, or in the top menu bar, and then over here in the charts area go to where it says scatter. And I like to use the scatter plot with the smooth lines. You don't have to use that. You could just use a scatter plot, but it's nice to have the line there. And so I choose that as my plot. And here it's giving us a graph of the motion. And my numbers weren't very good because it shouldn't have had a little bump right there. But I'm going to go ahead and click on this and then hit the delete key to get rid of that. I don't want that Series 1 label in there. I do, however, want a title at the top, and I want a label on my y-axis and on my x-axis. So here's how you can do that. You'll notice at the top there's this highlighted area. It says Chart Tools. These 3 menu items are part of the Chart Tools. If you pick Layout, and then over here in this option, Chart Title, we want the above the chart title, and I'll call it something appropriate and wordy because we're always appropriate and wordy in physics. So we'll say something like position versus time. Simple enough. Or you could be more creative and put cart position versus time, something like that. And then click out of it and it'll have it there. Next we'll put in an axis title, our horizontal axis being the x-axis and our vertical axis being the y-axis. I'll go ahead and go into the Y, and I'm going to pick a rotated title, meaning that it will line up along the left column here, along the axis. So I'll pick that title, and we'll go ahead and highlight over that. and we'll put a title like position. And in parentheses I'll put centimeters because that's the unit of measure. You should always put the unit of measure on your graph as well. That way things like the slope of the graph, you'll be able to figure out what the units of the slope are and other such things. So there we have our position in centimeters on our vertical axis, and we'll insert a title for the horizontal axis. And since we measured time, and time is what's on the X, we will label it time and put our unit of seconds. And there we have it. That's how you make the graph. Pretty simple stuff. Now, for those of you who did not measure your distances from the start point, you measured your distances in between the points, hang on tight here. We'll show you how to do that. The rest of you, you're done at this time. You've done everything you need. Well, actually, one other thing you can do. Notice, before you tune me out here, notice there are no grid lines right here. It might be kind of hard to tell where all your dots line up. You can insert grid lines, horizontal and vertical grid lines, by going into this option here. And say you wanted more vertical lines, you could put in the minor grid lines. And you can put in more than you really need, but anyway, that's how you do that. So I could do the minor grid lines along the horizontal axis as well. And that's what you could get. So, that's how you do that. Now I'm going to go ahead and delete this chart, and I'm going to highlight and hit the delete key on this data. Now for those of you who did not record position from the start point, so you don't have a true displacement from start, you have the displacement from the previous spot. Here's how you would do that. I'm going to retitle this column change in position, and I think I can spell it right. And then I'm going to call this cell position, and I'll have my centimeters up there. And I want to quickly highlight in between the cells here. If you go up between columns B and C, you'll notice it gives me this double arrow. If I double click, it will expand that column, and likewise over here so that it'll fit correctly. Change in position. So I'm again making up some data here. Let's say your first position to your second position, the distance was 0.3 centimeters in between them, or 3 millimeters. Let's say the next one had a distance of 6 millimeters, and so on. So I'll keep on putting, again, these are the distances between dots. If you did not do this, you shouldn't be watching. You go home and do your homework. Or you are home. Well, never mind. I'll quit talking now because I can't talk and type at the same time. And we'll just keep on putting different changes in here. Say you were really accelerating. And I doubt you had this much space in between dots on your lab unless you really had your ramp up high, but 6.3. And let's say it starts to taper off. There's less distance between the dots now because the cart will be slowing down. And we'll call that enough for now. Alright, so these are the distances between the dots on your tape. So if we wanted to figure out how far they were from the starting position, and again, this is not the ideal way to do it. So if you did it this way, remember, it would have been better probably to measure your position from the start point. But, however, we can still use this data. It's not a total loss. Right here, to find position, this is the change in position. So assuming we started at the start dot and then measured it to the second dot, that was how far it was. So that's the actual change in position from the start point at this first spot. So I'll write it down as 0.3 because the change in position from the start point to the second point, it'll be the same as our position from the start point. Now for the second one, our position from the start point for the second or the third dot will be the distance between the second and third dot plus the distance between the first and second dots. So here's how we will do that in Excel. You'll go into the cell you want to put it in and hit equals, and we're going to click this cell up above, and equals tells Excel that we're going to enter in a formula. So I'll put equals, and then I'll click on that cell up there which has our first position, the position of the the first dot past the start point. And then we're going to add to that the change in position from that point to the next point, because that's going to tell us where we're at right now. So I'll hit the plus key on the keyboard. I'm back up there. So hit the plus key, and then I click on this cell, which contains the distance between the second and third dots. And that will be our running total. Now, kind of like we were dragging these earlier, we're going to drag this. Unless we tell Excel to look at these cells continually, when I drag a formula, it will look at that same position relative to the cell it's putting the data in. So like right here, I chose the cell adjacent to it up above and the cell adjacent to it on the left. It will continue to look at the adjacent cell above and to the left as I drag that formula down. And if I wanted to verify that, I could click. And I click on that formula, I see it's C3 plus B4. So C3 is here, and B4 is here. So it is adding the adjacent cells. And then again here, it's adding C4 to B5. So it is doing what I want it to do. And our running total is what we're getting. So at 1.2 seconds, we're 40.9 centimeters from our starting position. And that's how we can calculate that. Now for graphing this. These cells are not adjacent to each other, so you can't just drag and do this. You don't want to graph the middle. The middle data you don't want to graph. We just want to graph this column and this column. Here's how you can do this in Excel. Go ahead and highlight the time cells, then click on your control key, or sorry, hold your control key with your finger, and don't click your mouse at this time. My finger is not on my mouse. I'm holding down the control key now, and now I'm re-clicking and dragging. And you'll notice that the cells to the left are still highlighted. So I have two non-adjacent columns that are highlighted. And then if I go Insert and I choose my plot, it will choose the cells that I have chosen. So our graph for our data looks like this. And that's a pretty good set of data right there, actually. I did good at inventing those numbers. And then you can put in, as I mentioned before, go ahead and put in your titles and your axis titles as we did previously. And that's how you can do that. If you have questions about it, please bring them to class. Otherwise, here's how you do it. And we'll get some good lab data from you. And anyway, good luck.